Okay, start review, day 8. And here we go. This one's real quick. Graph coordinate grid. Rotated. Counterclockwise. Rotated means what? Congruent. Remember that. It's congruent. So this should look for that. Okay, equal. And the same. Sorry, it's writing funny. Okay, so that one's out. That one's out. Greater than is out. Congruent is in. Super easy. Okay, let's see. So transformation is applied to a figure to create a new figure on a coordinate grid. Which transformation is not preserved congruent? That's basically saying not congruent, right? Not congruent means dilation. So just look for dilation, out, out, there she is. This one right here. Remember this one, we've covered this one several times. So if I have this square here, and if I rotate it, the first one we covered was translate, and then we had rotate and reflect, and those were all congruent, right? So if we did any of those, we want this figure where it doesn't land back on itself. So we want the figure to be moved from one place to another place. So if we turn it, it will wind up back on itself. If we flip it over, this top would go to the bottom, this top would go to the bottom, vice versa. Sorry, I gotta sneeze. So then, the only way the vertices would not land on itself again would be if you slid it over, okay? If you got this figure here, I don't know how to do it with these tools. Let me see if I can go. Let's see, right click. No, I don't know how to do it. But so, just leave it like that. So basically, when it's going to be slid over, slide it over like this, it won't land back on itself. Sorry for right here, guys, but that's just the way I had to work out. Quadrilateral KMP is dilated, so it's dilated by a scale factor, okay? So dilated means to multiply, don't forget that. Multiply by a scale factor of 3/4 degree quadrilateral K prime, M prime, P prime, T prime, the perimeter. Okay, so it goes to that stuff right here. Now remember, if we give a perimeter and talk about scale factor and dilation, you get the scale factor and you just straight up multiply it times whatever the dimensions were. In this situation, it's x. So if they give the area, if they mention area, you get the scale factor and you square it and then you multiply it. You give the volume, you get the scale factor and cube it and then you multiply. So this is what basically we come out here. They mentioned perimeter. So I'm just going to look at this part right here. This is the one I'm going to look at. So you basically get the scale factor, and the scale factor for us is 3/4. So you multiply the 3/4 times whatever they gave you. In the situation, they said x, 3/4 times x units, which happens to be b. Okay, math teacher observed that number of hours students studied, their multiplication facts increase. Okay, so the numbers that they studied, their multiplication facts increased. The number of errors the students made in the multiplication test decreased. So the more they did something, it's like this. It's a graph that the further you go this way, more it goes down. So it looks like this right here. It's like D. Okay, so the time you study, the more you study, more hours, the lower your errors are. Okay, so this is like a lot of errors because you haven't studied much, but now you studied more. Now these errors decrease, so it's going to be a negative trend. There it is. Okay, so list of 6 heights. Students. Okay, what's the mean absolute deviation? So that's MASAT. Okay, so you want to get the mean absolute deviation by adding, dividing, subtracting, and then dividing again. Okay, so let's add them all up and get these numbers here. I'm gonna hold on. I'm gonna pull it to this side. And get the calculator. Do it all one time on the calculator. Okay, so I'm gonna get the numbers are gonna be what 63 plus 70. We're getting the mean right here. Okay, plus 68 plus 73 plus 58 plus 67. Enter it. And we get all of that and divide it by, let me see, 1, 2, 3, 4, 5, 6, 63, 70, 68, 73, 58, divide it by again 6, right? 1, 2, 3, 4, 5, 6. So we get all of those and divide it by 6. Okay, so I'm gonna just go Control Enter. Oh, great. No, we'll just go here. And the number was 399 divided by or over 6 decimal. So 66.5. Okay. So now for each one of these, I'm going to get the bigger one, which is between 66 and those numbers there themselves, each number itself, and figure out how far they are. So I'm going to go here, parentheses, and I'm going to get the bigger one, which in this situation would be 66 minus 63, 66.5 minus 63. And I'm going to go plus, parentheses, 70 minus 66.5 plus, parentheses, 68 minus 66.5 plus, parentheses, 73 minus 66.5 plus, wait, 66.5 minus 58. Remember, I'm always putting the bigger one first. Plus 67 minus 66.5. So all that gives me 24, and I'm going to divide that by 6, and it gives me 4. So come back over here. I should just look for the answer 4, and there she is. So again, don't forget to do, come on here, you add them all together, divide by the number, and I divide over here by what, 6? So it gave me 66.5. Then I figure out how far each one was from 66.5. I always put the bigger number first, and then I added them all up, and they gave me 24 divided by the number of numbers, and then they gave me 4. It's pretty easy. It's not too bad, guys. Okay, next question. Okay, took 2 loans out from the bank. Henry took 4-year loan, paid annual simple interest. Simple interest, okay, both simple interest. What's the difference between the amounts of interest Henry and Ingrid paid for the loan? So it's the amount of interest. We just care about the interest and we care about the difference, which means to subtract. Okay, it's pretty easy. So we're going to go, I guess I can do the work right here. For Henry, I'll put HI for Henry's interest. We're going to go with I equals P RT. Henry's interest is equal to 5,000 times 4.2% times how many years? 4 years. And when I have the calculator, I'm going to go ahead and change it up, and I'll do for both of them at the same time. Okay, so you can just have it set up right here, and I'm going to have Ingrid's interest, PRT again. Ingrid's interest at PRT would be 5,000 at 3.9% times, I need a year of 6. Yeah, put a year 6 there. So I'm going to get my calculator and just type all that in there, right? Actually, I'm going to do it fast. 5,000. I'm not going to do the ends off just because I'm going to save it on time. 4.2% times 4. Remember that right there is Henry's. Ingrid's now is going to be 5,000 times 3.9% times 6. I want to find the difference, or find the difference. 5,000, 3.9% times 6. Wow, that's a big difference. So I'm just going to, okay, since that was the last one here, I'm going to press up minus the one from right above it. And there's my answer, 330. So my answer would be 330. Ooh, 330. Does it have a spot to put it, or is there a way to put it here? Okay, so now it's open-ended. Oh, no, there's the answer choice right there. Oh, I did all the work. Okay, so new. Okay, so a business owner opens a new investment account for 10,000 deposit with a 10,000 deposit. The investment account earns 2.5% interest compounded annually. Okay. He does not plan to make any deposit or withdraw, so basically the money stays there. They want to know how much interest earned the first and the second. Okay, so we're going to put that in the bank for 2 years. You will earn interest the first year. This is year one, and second year they earn the total in interest for the second year. Okay, so this is year two. Two different questions here. For this one here, we're going to go with. Remember, when we do this formula compounded annually, we're going to have A equals P1 plus R to the T. When we do this one, it gives me the total. So once I get this A here, I'm going to have to come back here and actually subtract the principal to give me the interest. Okay, the total gives me the all together. Remember, I always have it as A as all together, which I like to say is also your total, your balance, all that good stuff. So let's plug in the numbers here. A is equal to 10,000. 1 plus, what is that first? 2.5% to 1 year. Okay. So then I want to do this. That's of 1 year, right? But then whatever I get, I want to have to subtract whatever I get. I want to do the work here, and it's on the calculator. I'm going to subtract the principal of 10,000, and that'll give me my interest. Okay, A, this is my A minus the principal, and that'll give me my interest. So let me come back over here, get the calculator, and my okay, there it is. I can see it all. 10,000. That's 10,000. Parentheses 1 plus 2.5% raised to the 1 year. Yeah, that'll work. So I get 10,250. And minus 10,000, you can do that work in your head. That's 250. So 250 goes right here. That's at the end of 1 year. So I'm going to go back over here. I'm going to copy it down. And the only thing I need to change is that number up here. I need to put a 2 because they want to know at the end of the year. 2. So now here's 10,506. Okay, I should have written it down here. So for year two, right here, year two, we're going to go with the same thing. A equals 10,000 and 1 plus 2.5% to the 2, which gives me, shoot, what was it? I think it's 506, 25. 10,506.25. Let me see. 10,506.3. Okay, so there it is. And they actually gave it to me 3, so let me just double check on that one. Press up, enter. Yeah, it's 25. So there it is. And again, remember, we're going to have this as my all together. We're going to have to subtract the principal to give my interest. So we're going to go with a 10,000 so forth minus the 10,000 original principal, which would give me 506.25. And that one's there. That's not too bad of a question. Took it out to write and explain, but it's not too bad at all. Okay, so let's come on here. Table shows the cost per year attending the different types of college. So cost per year, 4 years, 2 years in the state, 4,000. Public 4-year in state, 11,000. Public 4-year out of state, private 4-year. Okay, so what's the question? A student is planning to attend a college for 5 years. Okay, okay, cool. The student has saved 1,200 and plans to save another $50 per month over the next 60 months. Okay. Based on the information on the student's plan, which statement about the possible choices for a college are true? So I see, if he does this, he already has 1,200. Now he wants to do 50 for 60 months. Okay, so I'm just going to get the calculator over here, and we're going to go that plus the 50 times 60. We can actually do this in our head. 6 times 5 is what? 30. 6 times 5 is 30, and 0, 0. He's gonna save an additional $3,000, and he has already 1,200. So basically, he has $4,200. Okay. The student would be able to afford the cost for 1 year at a private four-year college. What? Well, if he did 1 year at a private four-year, this one divided by four is how much? 9,000? No way. That's like over a $9,000 one, so not even close. The student will be able to afford out-of-state costs for half a year at a four-year public college. Four-year public college. Let's go for that one. Four-year public out of state. Out of state. So right here. Half a year. 4 year out of state college. Cost per year. So to go for half a year, he would use, or it would cost half of this, right? Which would be what, 14,000? And it's saying the student we would afford out of state, make sure it's out of state, for half a year at a four-year public college. So for half a year, he would have to use actually half of that, right? So he only has 4,000, so that one's out. The student will be able to afford an in-state cost for half a year in a public in-state, okay, in-state for half a year at a four-year public, half a year. That's a whole year, so divide that by two. That's 5,500. No way, he can't even afford half of that. Okay, so we'll be able to afford an in-state cost for 1 year at a public 2-year college. That's it. Because he has what, 4,200? So he'd be able to go to that one. Okay, that was a lot of reading. Not too bad though. Okay, so this is just a Venn diagram where the numbers go. So I'm gonna tell you this one right here. I always remember the thing that we talk about: car wins in race. So car is counting numbers, and then we have a bigger set here with the whole numbers, then the integers, and then the rationals. And then with all that madness, you have the other group over here, which are irrationals. So they're just different. Act crazy. Okay, look, I think A is my answer. Because rational and irrationals, they don't go together at all. It's like saying you're pi. You can't be a pi number, be here, and then over here rational, because we're saying that the pi don't make sense. So I think that's my answer right there. Yeah, that's it. Here you're saying you have some that are crazy and normal. Nope. Here you're saying all the rational numbers are all crazy. No, that's ridiculous. Yeah, these just don't make sense at all. So A is the answer. Okay, so here the coordinates of vertices of yada yada. So A, B, C, D. Okay, question is which measurement is closest to the distance from B to D? So we want B to D here. Okay, there's my right triangle. Y'all see it? Let me zoom in. So I'm going to count here 1, 2, 3, 4, 5, 6. And we're going to count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have a right triangle here. This is a right angle. And here's my right triangle. These are my legs. So this will be A. And this will be B. Remember, A and B don't matter. You can switch them around however you feel like it. So we're going to go, remember, these are your shorter legs. This one has to be longer. So it cannot be that one. It cannot be that one. Usually they have 6 plus 12 gives you 18. They usually have that one, but I guess they're kind of slacking off right now. So we're going with a Pythagorean theorem. A squared plus B squared equals C squared. I'm going to go with 6 squared plus 12 squared. Is that equal to C squared? So let's take that out. I'm going to come out here and go with menu 3, 1. Oops, 1. I'm going to go inside. I'm going to go with, I think it was 6 squared plus 12 squared equals C squared. And I do comma C. About 13.4. And there she is. Pretty easy, guys. Not too bad at all.